Okay, with the knowledge of integral, now we can talk about average power and root mean square voltage. So the definition of the average power will be 1 over t and integrate from 1 to t, like a period, over time. And we know that P equals to IV, and using Ohm's law, we ended up having V squared over R. And plug it in, we get this. And we assume that we have a sinusoidal voltage. Plug this thing into our equation from here. We have that V naught is a constant, so V naught squared over T R integrate this over time. There's a trigonometry, we know that 1 minus cosine 2 omega t over 2 is sine square omega t. So we can basically plug it in here, and then we ended up having two separate integral. Integrate from 0 to t through a constant, and then a sine and a cosine to a half cosine omega t, cosine 2 omega t. So this integral, remember the integral is basically calculating the area under the curve. So when we have a curve like this, is a square, so it's t over 2. For that, we have a sinusoidal oscillating, which is 2 period of this, of 2 omega squared. So we have 1 of that, and 2 in total, and then minus those 2 negative. We added up to 0. So we ended up having a average power equals to V naught squared over 2R. So let's say about the root mean square of a voltage. So the definition of root mean square is basically if we consider the power using a DC power, DC voltage to supply a resistor or whatever, instead of an AC. If we use the DC of VRMS, it will produce the same power. That's why we ended up having a average power equals to VRMS squared over R, which is the normal power equation of power. But so we have a relationship of VRMS equals V naught over square root 2. That equation works for sinusoidal voltage supply. So here is a more intuitive understanding of that. So if we have a sinusoidal, and then there's our VRMS, so the effective power that it gives it is the same.